discovered it. See how easy it is? It's on camera too. I can't edit any of this stuff. That's just going to be there for the world to see. All right. I was doing that to show you the common mistakes. That's quite easy. Oh my goodness. There we are. Oh, okay, 1.25. Can't believe I did that. Okay, so now what you want to do is percentile. Just think, you're supposed to shade in all the area below. So let's do that. That's what we're trying to figure out. That area goes right in there. Now, how are we going to figure that out? No, it's more than 50%. But you have to figure out exactly. The very last page of your exam is going to look like this. In fact, this is it. I just tore it off the Spring 13 exam. Didn't realize I did that. Okay, so there it is. And this is going to be your exam. And what do we want to find out here? 1.2, we know the z. So we look for 1.25. 1.25, you see where 1.25 is? Right here. And this right here, look at this. All this gives you is the middle area. This you don't need to know. So this is the middle area you're going to get. That's what this is. So you go 1.25 is this right here. 78.87. Now, just because it's easier to grade, and for us right here, it's easier to do it in our head, you can always round that to the nearest whole number. All right? In fact, I'd probably ask you to do it. If you didn't, you're not going to get points off, but it's easier for us. If you round, oh, there's the directions. Round it to the nearest whole number. Makes it so much easier. Okay? So we're going to round that between 1.25, first of all, 79%. Now, that's not 79%, it's between 1.25 and what? Negative 1.25, negative. That's the 79%. All right, and we want all the area. So we just have to get the area of that piece as well. And the key thing is that the whole thing adds up to what? 100. So, these two pieces together are going to be 100. These two together are going to be 100 minus 79. That, 21. That would be 21 together. But we just want half of it. So it's going to be 21 divided by 2. So that will be 10.5, and that one's 10.5. But the percentile is 79 plus 10.5. Does everybody see? Add those two together, what do we get? 89.5th percentile. Does that make sense to everyone? All right, next one. It's so easy to make a careless mistake. Okay, next one. Now you are given the z-score, z. All right, so what do we want? Why don't you go this way first? Turtle. Is z is negative? What does that mean? It means he's below average. He's slow. Turtle is slow. And he has a z-score of negative, here's negative 1, negative 2, about right there, negative 1.75. And his percentile, he's below average. He's below average. If he was right at average, what would his percentile be? If he was right at the 50%, if he was right at the z-score of 0, what would his percentile be? 50. So it's going to be way below 50. What's this little area here? That's what we're trying to figure out. That area is. That's his percentile. So, look here, and we have to get the middle area between negative 1.75 and 1.75. That's all this chart's going to give us, is the middle area right there, right in there. This chart's going to give it to us. So we look for negative 1.75 on here, and we don't find it, because it's all positives. But does that make a difference? No, because we just want between pots. We just want this middle area. So we look up positive 1.75, and it's 91.99. Now that is round to 92 for sure. So we have the middle area. Now, but the percentile is this. Everybody sees really low percentile. So together these are what? Two tails together are going to be what? 8, because 92 plus 8 is 100. So this is going to be the 4th percentile. That's going to be 4 too. I think I asked you on here to fill in, you know, that's 100%. Any questions on that? Whoops, now this one. A lot of people like to do this one by just solving. This is the z-score, and then solving for the value. But you know what? I mean, that will work, but I think it makes more sense. It's just more intuitive to think what that means. So instead of plugging this back in for the value, and you know your average, plugging this in for the z-score, plugging in the average and the standard deviation and solving for b, it's so much easier, I think, and more intuitive to think, okay, all right, this is the z-score. We want a speed, right? So start at the average and just go down. Start at the average. What is the average? What's the average speed? 100. Just start there. You know it's going to be less than that, and that's what this z-score tells you, because it's negative. It tells you to subtract. Negative. So what are we going to subtract? 1.75. So is our answer 98.25 miles per hour? This is miles per hour. This is a z-score. It's like a common standard ruler. You can't subtract that. You have to change that to miles per hour. This tells you 1.75 what? What are these things? These are standard deviations. So you have to just put right in there the standard deviation. Put right in here, this is the average. So 100 minus 1.7, not miles, but times 20 miles per hour. That's what you want to subtract. Okay? Does everybody understand that? Okay? So what would that be? 100 minus 1.75 times 20 would give you, just do it on your calculator, I should have been able to do that in my head, but that's 65. Okay? 65 miles per hour. Does that make sense? Questions? What if that was positive? What would you do? You'd say 100 plus 1.75 times 20. All right, let's go to the next one. The next one says HUD is in the 15th percentile. That's low. 50th's in the middle, 15th low. 15% of the curve is equal to low. So, where do I mark that on here? 15% look means that gives you your left-hand tail, doesn't it? Doesn't that give you your left-hand tail? So your left-hand tail is going to be 15%. Now I've got to get a z-score. And we're using this right here. So now I know I'm using this. Right here is 15%. So I'm going to have to draw another one that's 15% to get the middle area. So I'll do that. Draw another one. And now, what's my middle area? Have to be 70%. So that's the middle area that I want to look up to use this chart. So now, I want to look up 7. So I look at the middle area. There it is. Go down, 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 down. Not 7, all the way down to 70. Well, 70 isn't exactly on here. So what you can do I give directions for this? You can go to the front, I do, it says go, you can go to the nearest line on the table. So 70 is right here, you can go, that's closer to 70.63, so I would just go right over to 105. You can go to the nearest line on the table. Is that okay? If we said 1.04, that would have been all right. 70 is closer to 70.63, so don't say 1. If it was 68, you'd say 1. Questions on that? So we're going to have a z-score of 1.05. All right, right there. Now be careful here. So 1.05. So 70 is between 1.05, negative 1.05. That's 70. But I want so which one do I want? 1.05? The 15th percentile is going to be negative. This is the most common mistake that people make. So just put 105 there. But that would have to be, what percentile? Okay, let's put here. You see why it's negative 1.05? Because percentile is what? Less than 50. It's a little below average. Negative. Right? So, any questions on that? So now what do I want to do? Now I've got to get the speed. So let's do it without using the formula. I think it's more sensible. Let's just do this. 100. Start at the average, right here. And we're going which direction? We're going down. Left. And this tells you how far to go down, how many standard deviations to go down. Negative 1.05 times 20. Right? Well, if it was just one standard deviation, you'd go down 20 to 80. But it's 1.05, so it's 100 minus 21. 100 minus 21, that's what that is. 21 miles per hour. So that's 79. Does that make sense to everybody? Questions or not? All right. Now, this next one says, HUD's evil opposite twin. The exact opposite of HUD. And he is a fast driver, very fast. He's up at the 85th percentile. 85th. I say no work is necessary. Just look at the curve above. Can you see why no work is necessary? Because the 85th would be 70 plus 15. He'd be way up here. He's as fast as his opposite is slow. So he's 85th percentile. So what must his z-score be? 1.05. See? Oh, because he's the exact opposite. Because why? Because 15% plus 85% equals 100. So opposites would be 10 and 90%, 10th percentile, 90th percentile, 40th, 60th. They'd be opposite. Okay, so now we know that it's 1.05. Just make it's the opposite. Look, this is positive, that's negative. Let's see. Oh, I'm so sorry. Make it busy. All right, opposites. Right? So now, instead of subtracting 21, what do you think we're going to do? Add 21. Yeah, so you can just add 21. Or, if you wanted to go back, it's the same thing as doing that. But why do that? You have this already, so you see 100 plus 21. So there you're done. That's it. Just as much above average as his equal opposite is below. Now, let's say I gave you this one first, the 85th percentile first. It's a little bit harder because you don't automatically know the tail, do you? You don't. So if I gave you that one first, and you didn't already have this, what would you do? You'd say, okay, 85th. So what would you know? You don't know either tail yet, but think about it. 85th means you're way up here. So you do know this right-hand tail. This piece has to be what? Because the whole thing has to add up to 100. It has to be what? What? 15. So that's how you figure it out. And then you'd put 15 here. And then you'd see, and you're supposed to make it symmetrical. And then you'd see 70 was in the middle. Okay? And it would be all Next page. Okay. Okay, so now this question says that on our first survey, I asked you how old is your father, and you was the average, it follows a normal curve, and the average age was 52 years with a standard deviation of 5. So you need this information right here, so this is what you're going to be using. Okay? And then it says, what percent of the fathers are over 55 years old? So you just have to change that to a z-score. So what do? Remember, z is going to be equal to your value minus the average over the standard deviation. That's your value. All right, so we'll just say 55 minus 52, which is 3 years. But in terms of a z-score, we have to divide by 5. So that's 3/5. I'm going to put that. 0.6 is your answer. Okay, so that is your z-score. Now, what's it asking? You want to know what percent are over. So you have to use this normal curve to figure out any percentages here. So mark this. Where is this going to go? 0.6 will go about right there. We want to know everything older. You have to read it carefully. It's not a percentile. It's not asking the percentile. It's asking what percent of the class has fathers even older than 52. And that looks like a sizable chunk. But certainly not the majority. To get that, again, we have to go back to our normal table. And what did I do with that? Right here. Okay, so now we're going to be looking up 0.6, and what do we get? 45 in the middle. 45 in the middle. Between 0.6 and negative 0.6. That is 45%. Right? So now what do? These two together have to be what? 55. So it's just going to be 100 minus 45, 55. 100 minus 45, which is 55, divided by what? 2. That is 27.5. Okay? So that's our answer. Any questions on that? Okay. Now let's look at the next one. What percent of the students have fathers between 40 and 55? Now we have 2 endpoints that we have to change to z-scores. Okay? Well, we already did this one. We know this one. Smart. We know this one, but we don't know this one. So we have to change 40 to a z-score. So what do? We'll say 40 minus, go way back up to the 52. 40 minus 52 divided by our standard deviation. You see where I'm getting it? One way up to 5. All right, so we've got that. And that is negative, because this is a young father. Negative 12 over 5, which is negative 2.4. You're going to be way far down in distribution. Anybody here have fathers 40 or younger? It's a young father. No. Probably some of you have grandparents my age. I'm sure you do then. Probably not great grandparents. Some of you have great grandparents my age? No. That would be scary. Okay. Now, we're back here. So, we want to know, what's the question asking? The question asks, for what percent? Whenever it says what percent, you have to use the normal curve. That's going to give you the percentages. What percent are between 40 and 55? And we have to use this scale here. So now we know 40 is right here. what? 0.6. I'm going to go up here to 0.6. And this is the area that we want. This is a little bit harder. That's the area. Does everybody see that? There's a bunch of different ways that you can do this. I think the easiest way, though, is because the curve, everything's symmetrical about 0, is I would just go right down here in the middle. And I divide it into 2 pieces, right? We already looked at this. We know this piece right here is going to be between 0.6 and negative 0.6. We already got that as 45%. Isn't that between 0.6 and negative 0.6? That says 45%. Can you see that? It's 45. Between here is this is 45%. So what do you think this piece right here is? 45 divided by what? Okay, so we've got that one. Now, how do you think we'll do this one? This one here. Well, we'd go between 2.4 and negative 2.4 all the way to 2.4. We'd have to look that up, that whole thing, and then just divide that by half. So we have to look that up. Does everybody see that? Right? Does that make sense? So we do that, and we're going to look up 2.4 here, and what do we get? 98.36. Did I say you could round that to the nearest? Okay. Yeah, I probably did. I probably shouldn't with that one, but let's just do it anyway. 98. Is it okay if we round? Okay. I gave you those directions. When it gets up high like that, you really should. Well, let's just do it anyway. 98%. Okay, I wouldn't mark off. So we have 98%. Now, what do we do? I just want half of that. So now I'm just going to add those 2 pieces together. Does that make sense? Does that make sense? 98 divided by 2, which is 49, added to what? 49 added to what? Thank you. And what do we get? We'll say 98 divided by 2 plus 45 divided by 2. And what did we get then? Then we should get 71.5%. That's what we want. Right? Okay. Does it look like right? When you get an answer, eyeball it. Does that look about right? Doesn't it look about right? Sometimes you can just, you can just see you made a really, hopefully I would have been able to see if I made that mistake. Questions on any of that? All right. Now, I hope you feel a little bit more comfortable with Chapter 5 material. I know that when you first started working on your homework, it was probably a shock to some of you. It takes a little while to get used to. I hope you feel more comfortable with it now. Do you have any more questions on that before we move off Chapter 5? Okay. You should do some more practice exams, as I said, as real exams. Don't peek back. You might feel like you understand it now when I'm going through it with you, but make sure you understand there's nothing in front of you except your calculator and the normal table, because that's how it's going to be on the exam. You do those practice exams. I'll post another one up there in case you've already done most of them. I'll post spring 2011. That's not up there. I'll do that tonight. Okay. Now, let's now start at the very beginning, because the other really part that people really have been having difficulty is with the experimental design. When you have a non-randomized or an observational study, things can get confounded because there's going to be other differences between the treatment and control group besides the treatment. So let's look at this study. This is question 1. We're on page 66. All right. It's small, so I'm going to read this to you. A recent study examined the medical records of 300,858 first-time mothers who had babies in Finland from 1996 to 2008. And what did they do? They compared the rate of premature babies born to mothers who never had abortions, mothers who never had an abortion, and compared what percentage of them had premature babies to those mothers who'd had one or more abortions. What percentage of them ended up having premature babies? Okay? And they found that the risk for premature babies increased with the number of previous abortions. So the women who had more abortions they had before giving birth, the more likely they were to have a premature baby. So they looked at this, and you see these two things together, and you naturally wonder, does having abortions actually somehow cause you later to give birth to more raise your risk for having premature babies? Well, it might, but you have to think, are there other differences between women who have abortions and women who don't? It could be the explanation. We have to ask ourselves this question because the women who had abortions chose themselves. They're not randomly assigned to have an abortion or not. There might be something else about them. Something else about their health status, something else. Not the fact that they had abortions. Something else that's causing that prematurity. So first off, first question is this an observational study or a designed experiment? A designed experiment means that the researcher actually chose who would have the abortions and who wouldn't. So obviously it's an observational study, right? Does everybody see that? They just went and looked, and they're comparing. It still has a control group. It still has a comparison group. They're comparing those women who chose, well, they and their doctors together chose, but the researcher didn't choose, to divide them up. He's just watching. These women already had abortions. He had nothing to do with it. They've already had abortions. This researcher had nothing to do with it. Now he's just comparing those who had the abortions to those who didn't, and looking at the prematurity rate of their children. So, based on the results of only this study, which of the following statements is best? Abortions cause you have an abortion. It actually causes mothers to have more prematurity. It causes premature babies. It raises your risk for having premature babies. Although this exact causal mechanism is not known. That's what this first one's saying, is the abortions are doing it. There's something about the abortion, having an abortion. You don't know what it is, but there's something, maybe it's like destroying some your uterus or something, so it can't function well to then support a full-term baby. It's doing something. You don't know what the mechanism is. Now, do you think the study supports this? Do we know that it's caused here? Do you think? It could be, but for sure we don't know. So I wouldn't choose that one. We don't know it's caused. We would if they were randomly assigned. There's a large group of women, everything else about them was the same, except some of them had abortions and some of them didn't. Everything was the same with a random variation. But there might be some systematic difference about those women who have abortions. It could be the true cause why we're seeing this together. So I wouldn't choose that one. You understand? Because it's an observational study. But whenever it's an observational or non-random, you cannot conclude causation. You cannot. You can just say the two are associated. Okay, let's read the next one. Yes, they're associated. That's what the study says. Abortion goes with prematurity. Yes, they're associated. and may cause first-time mothers to have a higher rate of prematurity. That sounds good. Let's read the last one. Abortions are associated with, but clearly do not cause first-time mothers to have a higher rate. Do we know that it's clearly not the abortion? You see these two things together. What do you think? Which one do you think we should choose? The second one. Because we haven't proved that it does cause, and we haven't proved that it doesn't cause. All we know is that they're linked together. We have to do further study. Does that make sense? We know they're associated. It could be the cause. We have to find out. If it is something about the abortions, maybe we change the procedures, maybe it'd be very shoddy, or maybe it's something else. It has nothing to do with abortion. You don't have to worry about that. How do you find out? Well, one thing you do is you think about what could be a confounder. That's what this next question is about. Below are either confounders that mix up the study, making it look like people are thinking, oh, it's the abortions that do this. Well, maybe they really don't. Okay? What are we talking about here? Could be this, or what? There could be some lurking variable, some confounder. This is the causal link here. This is the mechanism here that's doing it. But there could be something else about people who have abortions that really is causing prematurity. You see what I'm doing here? There could be something else, but not just anything, not just any cause of prematurity. You know, not just anything. What does it have to do? It has to explain why we're seeing these two linked together. It has to explain that. It has to make us believe somehow the abortions are doing it, so it has to be linked to both of them. Otherwise, it's just another cause of prematurity that doesn't explain why we're seeing this. Does this make sense? So something is causing abortions, or is linked to abortions and to prematurity. Make it look like this is doing this, but it's really not. It's a confounder, or neither. Neither would just be something that causes premature babies, but has nothing to do with abortions. So let's read each one of them carefully, and I want you to think where it would fit here. So let's read the first one. Let's think about it. Okay, the first one says what? Genetics. It's likely that certain genes influence the risk of having premature babies. So can it be, well, that couldn't be a causal link. That has nothing to do with abortions here. Could it fit here? Genes cause premature babies. But it has to also be that same gene that would cause abortions. Would that make sense at all? So then, what is it then? Either. Go to the next one. Infections. Abortions can sometimes lead to infections that damage the uterus and raise one's risk for later having premature babies. Abortions lead to infections that lead to prematurity. So where does that make sense to fit in? Abortions lead, this is how abortions are doing it. Abortions can cause infections, especially if you have a bad abortion, you know, a shoddy one, but it can lead to, it can mess up, you know, if you have, especially if you have repeated abortions, might be to damage your uterus. So it can't support a full-time baby. Doesn't it make sense to put that in here? Does everybody see that? Okay, so that's going to be your puzzle. Now let's look at the next one. What could go in here? Let's read what this says. Conflicted feelings about pregnancy. Women with conflicted feelings about pregnancy. They might be more likely to have abortions. If they don't, they're not sure they want babies. They might be more likely to have the abortions. They don't really want this baby. They're feeling bad. They're thinking, oh, maybe you don't want this baby. Think about it. If you don't want it, you might want to naturally cause an abortion. You know what I mean? You might want to, if you don't want this baby, you're not going to take care of yourself well. You might not eat well. You might just do things trying to bring on an abortion. or prematurely. Wouldn't that fit right in here? It's not the abortion that's doing it. It's that you might, to begin with, really don't want babies, and you're getting them in. Sometimes you're getting pregnant, you have an abortion, and thought, oh, I don't know if I want to go through another abortion. I don't really want this baby. Maybe you're just like, I hope it doesn't get to one. You know? Can't you see that happening? Wouldn't that be a confounder? Does that make sense? So that's how you have to think about it. I hope that helps you here. Because this is a really important thing to do, to learn when you're doing it. You see so many studies with associations. So any questions on that? All right. Now, if you had a randomized study, you don't even have to look for confounders. Let's do the next one. It's just to see the opposite. Okay? Let's look at this study. Oh, is that hard to see up here? So small. I'm sorry, but you have it in front of you, and I'll read it loud. Okay. Here. Okay. A study was done to test whether changing the atmosphere of a fast food restaurant to feel more upscale, feel more fancy, would change customers' eating habits. I thought this was really interesting. And it happened in our town, parties in Champaign. Went in there, and for the experiment, the researchers divided the Hardee's in Champaign into two sections. This is true. One section was kept as usual, and the other section got a fine dining makeover. Soft lights, white tablecloths, candles, etc. What they want to see is that changing it is going to change people's behavior. Now, is it randomized or not? Let's see what happens. As customers arrived, they were randomly assigned to either the fine dining room or the regular room. And all the customers ordered from the same menu. They didn't have fancier food or anything. But the fine dining room ended up spending more time eating, rated their food significantly higher, ended up consuming fewer calories. So think about it. The fine dining group, here's fine dining, and here's regular old parties, fast food, regular parties. And they were randomly assigned. So when there's going to be differences between them, they're not going to be, it's not going to be like all the certain type of people, all the people who, you know, have money and are used to fine dining are going to be on this side, the regular Hardee's come. No, there's not going to be any systematic differences. So if we see some differences between these two groups, it's pretty much sure to be the fine dining experience, right? Does that make sense? So let's see what happens. Oh yeah, they did rate their food significantly. So which of the following statements is best? Which one would you circle? Well, right away, you should notice this says random here. So aren't you going to circle randomized? Okay. Which of the following statements is best? It's a randomized control experiment. So we can conclude. Randomized, so we can conclude causation. We can conclude that the fine dining causes the changes. Because there's nothing else. We can conclude causation. All right? There's not going to be confounders. No confounders in there's not going to be confounders in randomized experiments. Because you give them all these conditions, and then the difference is these people, you know, any changes that we measure at the end, these people rated it much higher than these. Well, we don't have any differences. We don't have any confounders in here. So it has to be the fine dining. All right. So which of the following statements is best? This study only shows that the atmosphere at this particular fast food restaurant is associated with customers spending more time. Customers who chose the fine dining room might be the type of people who like to linger longer. They didn't choose it. Do you see how this is wrong? Does everybody know that's wrong? Did they choose? They were randomly assigned. They didn't choose it. don't have any other thing to point to. You don't have any differences between them. They were randomly assigned. And these had higher ratings. This is what happened. Higher ratings. These people had lower ratings. These people ended up, they liked it more. But there's no differences we can point to. They didn't choose this, they were random. So there's just going to be accidental differences. So if they, okay, so we're going to say, yes, it was the fine dining that did it. All right, now, it's impossible. So this is going to be it. Let's read, you can lightly circle it, but we might change our minds when we read the last one. It's impossible to tell anything from this study, since there's no way anyone can turn a fast food restaurant into anything resembling an upscale restaurant. Well, maybe that's true, but they did change it somehow. They made it more, there was, yeah, maybe they can't make it completely upscale, but they still made a difference. That doesn't make sense. They didn't make a difference, you wouldn't have seen these two. Okay, now, which of the following are likely to confound the results, making it look like it was the fine dining, when it was really something else? Okay, the fine dining did cause the changes, the higher ratings. It did, because there's no, you can't put something in the mystery box because it would have to be in here. If there was a confounder, if there was a, this is the right answer. It's not this, because if there was a confounder, think about what we'd have to do. If there was a confounder, let's pretend there was a confounder. Well, it would have to cause a higher ratings. And it would have to be some difference between these two groups of people. That's not going to happen in a randomized study. In a non-randomized study, yes, the people who chose the fine dining might be, this would have been a confounder. You know, any of these could be. You know, wealth, richer people are more likely to choose the fine dining. Older people are more likely to choose the fine dining and, you know, linger over their food and eat less calories and give higher ratings. All these things, if the people chose themselves, those could all be confounders. But they're not going to be confounders in a randomized experiment. Does that make sense? Do you understand? Okay. So you're not going to get it because the study was randomized. If it wasn't randomized, which one of these would be confounders? Age could be. Older people are more likely to choose the fine dining room. And more likely to eat slower. Yes, that would fit if it was non-randomized. We'd have fine dining, we'd do the same thing. Fine dining leads to all those changes, like slow eating. What else was there? Slow eating, less food, less consumption, less eating, higher, enjoying it more, longer time, higher ratings, you liked it better, higher ratings, etc. Or, this is if it was non-random, we let them choose. We would, it could be this, or we would be looking for a confounder. We'd be looking for something that causes the slow eating, slow down eating, which is good for you, causes you to eat less food, less of that richer food, you know, enjoy it more. Less food, but enjoy it more. All these things happen. And be connected to fine dining, but not because of the fine dining, but because of something else. It's not the tablecloth, it's not fancy lights and everything, it's not that. It's just maybe because it's old people who have the money to do both. They definitely eat slower and less. Have no taste buds. You say it's good no matter what. You know, so that could. And they're going to go to the fine dining place. Could be what else? So that it could be wealth. Definitely wealth could have been in here. Oh yeah, they linger over their meals and all that. They have all the time money. You know, and they're going to go to fine dining places, etc. Do you understand? How about this one? The pleasant atmosphere. Let's read this last one. The pleasant atmosphere of fine dining caused people to enjoy their food more, and not just gobble it down. So they rated the food higher made them relax on the side so that they could slow down. You see how that would be the causal link? Pleasant atmosphere? Blank faces. Good or bad? Probably was going on too long. All right. Done with that. All right, let's go back now. All right, now, we spent so much time on that. So let's quickly summarize these things. Okay, now, this is hearers and non-hearers. What is this whole study about? This is a study that starts off great as a randomizer. A study was done to test the effectiveness of a new weight loss drug. Half were randomly assigned to take the drug, and half were randomly. So it's a great study, and neither the subject nor those who evaluated them knew who was in which group. So that's a randomized what? Without a placebo? No, it's with a placebo. It's that one. Now, not everybody sticks with the program, so you can start off with a randomized study and it can go bad if you don't analyze it correctly. If you don't look at everybody, this is the total here is everyone who was randomly assigned to the drug and everyone who wasn't. You have to stick with this. The original assignment is random. You have to stick with that. These groups, these adherers, these people who follow the instructions, choose themselves to adhere, and they did lose weight. They probably are doing other things that help them lose weight. Exercise, they're more responsible. These are the slackers, the non-adherers. They should gain weight. All right? But the same was true with the placebo. So look at this. This is observational data within this bad, non-random data. We don't want to look at that. We don't want to we want to look at the final randomized. This is like using, you're going to get confounders if you look at that data. Look at the original random assignment and you see that what happened. Did it work or not? No. Doesn't look like it worked here either. But this is it's better to stick with this rather than to use data where people themselves choose and select themselves. So just ignore this stuff and do look at that, okay? Especially because sometimes you will have a control group where there's no placebo, like if it was about exercise, or about some condition where you can't have a placebo. You're not even going to see that. That's going to be all not applicable. And you don't want to compare the treatment to everyone. So just stick there, okay? So the drug worked no better than the placebo. That's true. The drug worked better than the placebo for those who regularly took the medicine. Well, if you regularly take it, it worked, still worked the same, so that's a no. It didn't work better. Adherers may be different, definitely different. They might be more responsible and everything, so yes. All right. Now, here's another example. This is an example of Simpson's paradox, where it's just it's an observational study where there's so much confounding that you can't trust this overall stuff because it's an observational study. You're not choosing like a big invasive tumor or a small little tumor, and you're comparing these two groups. Do male surgeons do better or female surgeons do better? So you look, you see the success rate was higher for who? For males. Right? Wasn't it higher for males? Watch this. Higher for males. Then you look overall, upside down. It's higher for females. Well, you're going to have one type of tumor or the other, and you would prefer a male. Right? So where is this coming from? This is similar to like if you had like you guys are good students. Pretend this is a good way to think. Good students and bad students. Slackers and you guys are probably good to be about. Okay? And you probably have hard courses and easy courses. You probably are going to do better on the hard courses than the slackers, better than the easy courses. But you could end up with a lower GPA if you took a lot of hard courses. And the slacker took all easy courses. That's why they weight your grades. So that's exactly what's happening here. The females, the not that they're slackers, I'm making this up, I'm just trying to get to the logic. The slacker types overwhelmingly are taking the easy courses, the easy tutors, much easier. So that's why you can't do this, okay? You can't look at this overall. You can do these on your own, is that okay? Because I want to skip to the next thing, I think we're getting, now that you understand the logic, is it okay if we skip to the next problem? All right. Now, let's see which ones are most likely to screw you up. Okay, let's look at this one. A list of 10 numbers, this is on the bottom of page 69. A list of 10 numbers, you're given the average, median, and standard deviation. And this question asks you about if you change the list, if you add, what's the first question? 5 is added to every number on the list. What does that do? It adds something to every number on the list. What's that going to do to the average? I'm just going to go through it in our notes. What's that going to do? If you add 5 to every number, what's going to happen to the average? Isn't it going to go up to what? 10 to what? And what's going to happen to the median? It's going to go from 6 to what? Add 5. It's going to go up to what? 11. Now, the standard deviation trick. Here's the numbers. Pretend there's a whole list of numbers. We're at standard deviation measures the spread. We're shifting all the numbers by the same amount. Is that going to change the spread? So it's going to say. Now, multiply. If you multiply, it would. If you multiply, it's going to stretch it out. So that will change everything. So multiplying will change everything. So multiply by -2. Negative 20. Multiply by -2. What do you get? Hello? Negative 12. Now, be careful. Multiply by -2 and watch what happens. Is that possible? Can you get a negative standard deviation? So just cross that out and you're left with an 8. You can't. Stretch it out, but you cannot have a negative standard deviation. Now, divide it by 2. We'll go through the same thing. Division is just like multiplication. Divided, divided. Now, this one's a little tricky. Because you subtract 10, that's going to affect the average. So you're going to go 10 and you subtract 10. The average is 10. So that would change it to 0. And then we're dividing by 4. So we get 0. Same here. Subtract 10. That's going to affect the median. And then you're dividing it by 4. So what do you get? -1. Now, you get to the standard deviation. You subtract 10. Is that going to change the standard deviation? When you subtract 10, is it going to change it? So don't do that part. It's not going to change it. Now, you divide it by 4. Is that going to change it? So that's your answer. And look at this. That's a z-score. What I did was subtract the average and divide by the standard deviation. That's what I did. So that's why we ended up with that. Now, every number on the original list remains the same. You have this whole list. Here's the smallest. Here's the largest. Here's your middle. Everything stays the same except what? This largest is going to go plus 10. It's going to go, instead of being here, the largest will be here. You see how that stretches it out? Does it stretch it out? Does it stretch it out? So what do you want me to put here? Increase. Pretend these were all increase or decrease. We don't have time, and that's what's going to be on the exam. So let's just think about it. What's going to happen to the median? Is it going to change the median? So that will stay same. Middle number. And will it change the average? Yes, anytime you change even a single number on the list. Make it that number bigger, it will make the average. Make it smaller, it will make the average smaller. So this will be. Okay. Now, which one do we want to do next? Oh boy. How about, should we do this one? So you're going to get that's worth a lot of points. Okay, so we're going to 68. Now, it's about reading a histogram here. All right? Area, these are rectangles. The area of a rectangle is what? The width times the height. So get the areas of each rectangle, so you are just going to multiply the width times the height. So that's going to be 5 times 2, 10. What's this one? How am I getting this width? It's 10. It's just 5 long. 10 minus 5. So this width is 5 times what? 5 times 5. So what's this going to be? 25. What's this width? Another 5. 15 minus 10 is times 3. So that's 15. How about this one? That's not 5 anymore. What is that? It's 10 long. 25 minus 15 is 10. 10 times 2.5. This one, 5 times 3, 15. This one, whoa, that goes all the way to 50. 20 times a half is 10. Now you add them all up, and what do they have to equal? 100. So don't you made a mistake. So even if it, always fill them all in. All right, now, it's 100%. Now, the median, everybody gets this mixed up because they think the middle number, they just look here, from 0 to 50, and they think, oh, halfway, that's the median. Why is that not the median? Because look how much more people you have. They're just standing on top of each other here. You know, you have a lot more people. It's just they're on top of each other. The middle number, if they're all stretched out. So it's the middle number by area, not by on the number line here. So you have to look for the area. And you want what? 25, you want 50%. So you have to go 10 plus 25. That's 35%. So that can't be the median. How about this one? Now do we have 50% on this side? We have 50%, and we're going to have 50% on that side. And so the person who has 15 pairs of shoes, that person's the median. Okay? Now, is the median bigger than the average or smaller than the average? The way to think about it is, does it have the extreme values here? Pull the average up. Pull the average up. Remember, we just did that. When you add 20 to something, it's going to pull the average up. It's not going to change that middle person. So this is going to pull the average greater than the median. That's what it's going to do. Be careful. That means the median is less than the average, because the average is greater than the median. People are going to get different exams with just tiny little changes. That's why this one, somebody else is going to get average. You're going to look the same. You're going to be sitting next to somebody with a little change. Don't cheat. Please. Oh, terrible story. Okay, what percent of the students have exactly 20 pairs of shoes? Because all these are intervals. How do you read this? Percent per pair. That's what the height tells you. So you look for 20. It's right here. And this says everybody in this block will have for people who have 20 pairs of shoes, they'll have 2.5%. If 21, 2.5. If you were in this block, I asked you, well, how many people have 27 pairs of shoes? You'd say 3%. That's what that height tells you. That's why you're moving, okay? What percent? Assume an even distribution. As long as we're assuming that it's even through there. All right, so what's our answer here? 2.5 is the height of the block. All right, we did that one. Now let's see what we have left between these. How about we do this one? All right. Now, what is this? You have to draw this histogram here. And you've been given the width. And here's the height. And this is the area. Well, height, area equals width times height. So height equals area divided by width. So this is going to be the area divided by the width. Area is 50 divided by the width is 10. So that'll be 5. Area divided by the width, here we get 1. 20 divided by 10 is 2. So 25 divided by 5 is 8. Now we're ready to draw it. And let's make sure it makes sense. All right, so how do we draw this histogram? This tells you 0 to 10. We're going from here, this block, and we're making it 5 high. And we'll say 10 times 5 is 50. That one checks out, that's right. Now we'll go to the next one. From 10 to 15, it's going to be 1 high. That's what this tells us. And 5 5 times 1 is 5. Yep, that checks out. That's exactly what we said. The next one, 20 divided, we said 2. Oops, interval. Interval is what? Between 15 and what? 25. And how high am I going to make it? How high? 2. I'm going to go all the way up there. And say, this is going to be 2, and 10 times 2 is 20. That one checks out. And our last one is what? We're going, this little 5, how tall should I make it? All the way up to 5. And that's 5 times 5 is 25. Yep, and that one checks out. So do you see how we drew it? Now, the median number of days. Where is the median? By area. That's 50%. Didn't even have to look at that. Just stick it right here. 50% on this side. All this is 50%. So it's going to be right here at 10. So that's the dividing line. You see that? Everybody see it? Okay. The number of people who answered, this is easy. Let's just move on so we can get this done. All right. Now, because you're definitely going to see something like this, and I don't want you to make any careless mistakes. Okay. So, 5 numbers here. So the average, just add them all together. What do you get? Those 2's cancel out. You get 5 divided by 5 is 1. Okay. Now, how about the median? Be careful. Arrange them in order from smallest, -2 to the largest. Right? And the middle number right there is the median. Now, deviations from the average. List them in order from smallest to largest. Have them from smallest to largest. So what are we just going to do? Deviations. Subtract the average from every number. So here's your average. What I want you to do is subtract that. So -2 minus 1. What's that? -1 minus 1. What's that? 0 minus 1. 2 minus 1. And 6 minus 1. Now, make sure you didn't make a mistake. Add these up. 5 plus 1, -1. This is what? -6, +6. They add up. They should add the check to 0. If they didn't, maybe you made a mistake with your average. Maybe you have to go back and figure out where your mistake was. These two. Now, compute the standard deviation. You have your deviations there. Start with those. What do you want to do with those? Square them. So you take -3 and you square it, you get a 9. -2 and you square it, you get a 4. -1 and you square it, and you get a 1. 1 and you square it, what do you get? 1. And 5 and you square it, what do you get? 25. Now, you want to take the mean and then the root. Root means square. Okay, the mean is just the average. Do it right here. Plus, plus, plus. Divided by 1 to get the average. What do you divide by to get the average? That is going to be, then we want to take the square root. So we take the square root of this whole thing. So what do we want? The square root of what? Okay, add all that up. I get what? 40 divided by 5. So it's the square root of what? 8. Which is about almost 3. I don't know what it is. You know what? 2.82. The reason why I want you to get that is because I want you to check it out afterwards and make sure it makes sense. 2.82. If you got 8 and you forgot to take the square root, you'll know it's wrong. It's bigger than any one of these. It can't be. It has to be the typical one of these. That's good. All right. Any questions before we stop? Yes. And everybody, we still have what? How many? 3 minutes? 4? Shh. Because this could be a very important question that everybody knows. It's the most important rule on the day before the exam. Absolute silence. So I say to go. Go ahead and ask your question. Actually, this might, I'm going to talk to you. Did I make a mistake, you think? Okay, so why don't, since people are getting antsy, how about I'll take a few questions, I'll take your question after so I can say bye to everybody, good luck, and I'll send you an email.